Okay, folks, so I'm going to do a quick intro into Jamovi. We're going to get Jamovi in. This sort of looks like you're in Excel, except you can do more things. Jamovi is like a free online pared down version of what you're going to see in 406 when you get into like SPSS. It has a lot more buttons. Jamovi is relatively simple. Okay? So you just download it from jamovi.org. Takes a few minutes to get set up. And then I'm going to have data on our campus page for you to download and just pull into there. Okay. So quick intro. You have like ID numbers over here on the left. Basically, each row is a person. And the data that we're using here is survey data I collected maybe 3 years ago. So it has variables like math, SAT, verbal SAT, GPA, height, shoe size, favorite candy, what year you are, where you prefer to study, lots of different things like that, okay? If you go up to these buttons at the top, you can start to see where you can, use some different functions. So in the like explore, we can get descriptives. Descriptives is things like mean, median, mode, standard deviation. We've been talking about t-tests. You can find different t-tests here. We're going to do ones with the one sample t-test, independent samples t-test, even paired samples. And then later on, we're going to do the ANOVAs in here as well. Okay. So let's say we wanted to start with doing some descriptives. That's a good place to start. So we can click here, and you can see that it pulls this table sort of in front of your data. But let's say we wanted to look at math SAT. Okay, we just throw it over, and this view looks very similar in SPSS. So if you're concerned about, oh, when I get an SPSS, I'm not going to know how to do it, it's going to be okay. And it looks similar. You throw variables over, and that's how it works. So you can even see it at the bottom already. I have math SAT, I have mean, median, and if I add mode, adds mode. If I want standard deviation and variance, it adds that. And so it just gets some of the descriptive information. The average mean SAT score was 587. The median was 600. Now, let's say you wanted to do, okay, what is math SAT by something else? So let's do it by class status, which will be like sophomore, junior, senior. Okay? You throw that in. And what's cool about Jamovi is that it just does it for you. When you get into SPSS, you're going to have to say, okay, now run this. The view is a bit wonky, but what you can see if we just isolate the mean, like you even take out things like mode and standard deviation to make it simpler. If we just look at the mean, we can see it by each year. Okay? We didn't have but one sophomore this year, 5 seniors, 18 juniors, and you can see those averages by class status. So that's kind of cool. If you go into t-tests, oh, we could do a plot if we wanted to down here. Okay? Histogram. It's making it, I think. It's not making our table. That's okay. If we wanted to do a t-test, let's say we want to start with a one sample t-test. We want to see, using that same variable of math SAT, we said the mean was, what, about 587? We could test this with a value. This value is the same way you would do it with, what is the population mean? Okay, so we know the math SAT is 587. Let's see if that differs from, I don't know, 550. Okay. And you can see this looks the same way we had those like alternative hypotheses. Two-tailed versus one-tailed. Okay. Mean difference and effect size are just kind of fun. Oh, and we have confidence interval. And descriptives. Just kind of getting some more data. Okay. And again, it's doing its thing over here. And we're getting some data. Okay. This is our t statistic. We asked, does math SAT with a mean of 587 differ from a population mean of 550? Our t statistic is 1.83. Now, we could compare this to a t-critical based on sample size, but things like Jamovi and SPSS do it for us. Okay, we have the degrees of freedom. There are 25 people. We also have a p-value. Now, it gives us, again, the specific p-value. So it's not like we're doing less than, greater than 0.05. It's giving us that value. If our alpha is 0.05, this p-value that is 0.08 is not in that critical region. So we would fail to reject this hypothesis. Again, this p-value, also in SPSS, it's going to have a sig instead of p-value, tells us if our result is significant. If it's greater than alpha, and again, let's assume alpha is 0.05. If it's greater than alpha, we do not have a significant effect. Okay, so we would fail to reject. Math SATs in this group are not significantly different than 550. Okay? Now, let's say I went back over here and let's manipulate this. What if the population mean is 540? Does that change it on our p-value? Enter, I think. Yep, it does. Our t-statistic is 2.32. Our p-value is 0.029, which is less than. So if we were comparing it to 540, we would have a significant effect. Okay, it's one sample t-test. Let's say we were doing independent samples t-test. Okay, and what this is it's saying, what is our variable of interest? I don't know. Let's move away from SAT. Let's use height. That's kind of random, but that's okay. And let's do height based on if people are thinking of going to graduate school. I haven't tried this one, so I'm not quite sure what it's going to look like. But basically, it doesn't have 2 levels. Let's do it based on if people had breakfast. How about that? That has 2 levels. We have 2 groups. We have an experimental and a control group in a sense. We have, did people have breakfast or did they not? Those are our 2 groups. And then our dependent variable is height. Okay. Again, we're doing this as a 2-tailed, but you could also do it as a 1-tailed. It's helpful to get some of these just to get more information. You can see it populating down below, which is neat. It's going to work on our plot. Hopefully that comes up. If we go up, thank you. We go up here, our independent samples t-test. We were comparing, do people that eat breakfast, I think 1 is yes, 0 is no, are they taller? It seems kind of random, and no, they're not taller. People that don't have breakfast, 65 inches. People that do have breakfast, if you round, 65 inches, okay? So it's not significant. We see that right here, okay? This piece is our t-statistic, 0.745. Again, we could compare that to a t-critical. Our DF of 23. Why 23 when the other one was 24? Well, we have 2 groups, 25 minus 2. And our p-value is 0.46. Again, we're comparing that with an alpha of 0.05. It is above the alpha of 0.05, so we would fail to reject. There appears to not be a significant impact of breakfast on height. Makes sense. It's kind of silly. Okay, that's just a quick intro into Jamovi. Again, I found those functions with the descriptives up here on the left, the t-test, 1 sample, and then we did the independent samples t-test. Hopefully that's helpful. Feel free to play around with this as well. You really can't break it. You can just click buttons and see what comes up. Okay, cool. Let me know if you have questions.